University. On behalf of the SIG, Advanced Learning Technologies, Learning Analytics, Platforms, and Infrastructure, in the Asia Pacific Society for Computers in Education, we'd like to thank you for attending today's webinar. It is our honor to invite Professor Carol Zhu to deliver today's talk. And I am going to introduce today's speaker. As you can see from the camera, Professor Carol Zhu. Professor Carol Zhu is a distinguished professor and the department chair at the Department of Computer Science and Information Management at the Suzhou University in Taiwan. Dr. Zhu received her PhD degree from the Department of Information and Learning Technology at National University of Tainan in Taiwan in July 2009. Dr. Zhu serves as an editorial board member and reviewer for more than 15 academic journals. Her research interests include mobile and ubiquitous learning, game-based learning, information technology applied instructions, and knowledge engineering in education. Dr. Zhu has published more than 115 academic papers, including such esteemed ones like Computers and Education, British Journal of Educational Technology and Society, and Electronic Library, among others. Owing to her innovative inventions in e-learning, she received the annual Young Scholars Outstanding Researcher Award, which is the Da You Memorial Award from the Ministry of Science and Technology in 2014. Moreover, in 2015, Dr. Zhu was selected as the Associate Editor of IEEE Transactions on Learning Technology and as the Guest Editor of Interactive Learning Environments in 2013 and 2016. Due to the implementation results in flipped classrooms in 2018, Dr. Zhu was recognized as top 50 higher education flip promotion teachers in the world. Subsequently, she won the Outstanding Information Talent Award in 2020 and was awarded by the President Tsai Ing-wen in the award ceremony. In recent years, she was ranked as the top 2% world scientist and was listed in many ranking systems in various international journals. So I can say that Dr. Zhu is really a world-famous international scholar, and we are very fortunate to have her share the recent research in today's webinar. Before we start the webinar, I just want to remind that the webinar will finish at the 10:15, and then from 10:15 to 10:30, we will conduct a Q&A session. And during the lecture, please use the Q&A feature instead of the chat feature. As you can see from the Zoom on the bottom, you can see the Q&A. Please use Q&A so that we can easily manage your question. You can also leave your question at the end of the session, which is 10:15. We have the Q&A session. And the topic of Professor Zhu's talk is graphical organizer-based in-field mobile learning. In this speech, Professor Zhu will introduce how graphic organizers can be incorporated into in-field mobile learning designs to stimulate deeper thinking and produce integrated learning outcomes of learners. By using graphical knowledge organization tools, learners are able to organize what they have learned by connecting the new knowledge to their prior knowledge during the in-field learning process. By now, I believe you cannot wait for any longer to listen to such an interesting topic related to the graphical organizer-based in-field mobile learning. So let's have a nice round of applause by using the emoji feature, the button in the Zoom, for our distinguished speaker, Professor Zhu. Thank you.
Thank you, Jerry. And Thank you for everyone attending this speech, and I'm very happy to see you here. And now share my screen. Okay. Okay. Okay, good morning, everyone, and I'm very happy to have this opportunity to introduce the graphical organizer based in field of mobile learning. And my name is Huijun Zhu, and my friends call me Carol, so Jerry call me Carol, and you can call me Carol too. And in recent years, research concerning mobile learning and we call that self-regulated learning has made great progress. So in Taiwan, we also have the SIG that is Comtel SIG for mobile learning since 2006. So you can see that it's almost 17 years we concerning about this issue. So in here, okay. Here, before I begin my talk, I would like to take a moment to introduce my research lab, the Mutel Lab. The Mutel Lab is the mobile and ubiquitous technology enhanced learning lab. So over the years, we have received fundings from various teachers institutions, including National Science Technology Council and the Ministry of Education and the Ministry of Health and welfare and in Taiwan. So almost we receiving about 4 million NT dollars in funding per year to do the mobile learning and game-based learning some topic here. And so that is so many courses we are doing the research, including digital humanities, natural science course, just you can see English and the computer engineering course, medical education, and so on. And so the background of our team, including 2 teams work together. And the first team is computer science, another is educational technology. That is what we focus for language therapy, computational thinking, and mobile learning, AR, VR, and game-based learning, AI in education, and also flipped classroom. Okay. So that is some academic reward. Just Jerry just introduced me, so I skipped that. And in the Comtel that is what I remind to say that in since 2006, I have served the convener of the Comtel in Taiwan and 2015 to 2019. After that is Jerry to serve the lead of the team. Okay, and that is the photo. We meet together every year. We have some events and we have some conference together and to think about what we want to do next year. Okay. Okay, is my wireless okay currently?
Yes. Yes.
Okay, thank you. I'm fear about that unstable. Okay, and except for the professors from different university, we also cultivate the students of our students. So many universities from 10 or more universities in Taiwan. So every year we have 100 to 200 students attend the meeting, and we have to cultivate them together. And we also have so many friends in the international research cooperation. For example, Hiraki Ogata, Professor Hiraki Ogata, and Professor Chen Jiu, and Kim Suk, and Professor Kim Suk, and Professor Petrine, and Min Watt, and Professor Jiki Lu. So we welcome you. If you want to connect with us and for this topic or others topic, you are welcome to Taiwan. And that is some publications, and I also have the academic service. You are welcome to submit the paper to Educate Translation Learning Technologies. Jerry just said that. And also the Journal of Internet, and another important journal here, I want to introduce that International Journal of Mobile Learning and Organization, IJML. That is the editor is Professor Guo Zhenhuang. This AGM is now the Q1 journal in Scopus and also listed in APSCE, and we want to see that it will be added to SACI soon. Okay. And that is a very good reference about mobile learning. That is the whole journal talking about. Okay. So we can see the photo here. In the past, even we talk in the past, the currently is still ongoing. It's online learning. We use desktop computers and wired network, and later mobile learning, mobile devices became popular. So we talk about the mobile learning, right, and the ubiquitous learning and wireless network. But in the future, near future, or just we have some experience about the new era is intelligent technology. We use augmented reality, virtual reality, mixed reality, and the AI in the different technology, and also data analysis technology. So that is the era of smart technology, enhanced learning. So what we have faced today, we have very big change. The first change is the changes in the way we learn is totally different. After this year, after ChatGPT, after ChatGPT 4, 5, it is totally different era here, and change in the role of the teacher, and we change the learning context. So there is so many changes here, and we face at least 3 types of change. So in the mobile learning, we can know that the emphasize the mobility, so and the access to the educational material. That is mobile learning. While you learning, ubiquitous learning focuses on the creating an optimal learning environment for students. So we can conclude that by using mobile device to create flexible and seamless learning experience, we can create an ideal educational environment where students can thrive. So let's see what other countries do in the tablet policy adapted by 3 countries, including Taiwan. The first one is Japan, GIGA project. In the project, it aimed to build a high-speed network environment and implementing the policy of 1 device per student, just like us, just like Singapore, and developing learning support systems and using the AI technology for personalized digital learning. It's just also like what Taiwan I'm going to do these years, and provide students with equal educational opportunities. And in Singapore, okay, that is multi-stage EdTech plan involves building hardware and software systems, and the current plan emphasizes the use of technology to enhance students' self-directed learning. It's also quite the same with Taiwan. And communication skills with the focus on technology-based and student-centered assessment. So using also promote the BYOD strategy with the device to student ratio about 1 to 3. Okay, and so in Taiwan, in 2022 to 2025, the 4 years, we want to do that internet in every classroom, tablet PC for every student. So it's about 4 years, and the fundings are 200 billion for the 1 to 12 graders, and there are 610,000 mobile devices will be spread to the students, and also there are 2,400 classes will be implemented with BYOD. Okay, we can see so many countries will do the same thing. And what is the next step after giving tablet PC to students? Is that end, or it's just the beginning? In the new age, a teacher needs to learn about one thing: is to smartly and appropriately plan, integrate, and use technology in the classroom to fully demonstrate their teaching wisdom. That is very important because currently all students maybe have one tablet PC, but after that, what is next? So in Taiwan, we talk about the 5C competencies almost in 2013, is 10 years. So the first one is critical thinking. That is the ability to clarify objectives, identify key points, and question assumptions. And the second one is creativity. That is innovative and valuable thinking. Okay. And the third one is complex problem solving. That is the mathematics problem is complex, the real world. So the ability is to identify, to define and identify problems and analyze the problems and gather information from several ways and propose solutions, attempt to solve them, and then reflect on the process. So, and the fourth is communication, and the next one is collaboration. So we know that, and earlier mobile learning, because we have the SIG since 2006, so we have to many researchers about mobile learning. In the earlier stage, we use the mobile device to serve as a tutor. So the tutor, personalized tutor, to help the students learn in different learning progress in the authentic learning environment and to guide them to learn or practice in the real world. Okay. So the first one I want to introduce the old age, but it's also very good because they have different ways, right? Different learning progress. But we use the context-aware learning approach in the scientific museum. So they do the scientific inquiry activities in the science park. Okay. So in this study, the students are use the sensing. We use the sensing technology to detect and examine the real world learning behavior of the students, such that personalized learning guidance and feedback can be provided. So that is what the research focus on. So that is the park. It's a museum park, museum science park, located at the southern part of Taiwan. Okay, there are 9 devices, okay, are selected as the target learning objects here. So the students need to learn here, and they are on move. So each target is labeled with RFID. With that, in that stage we use PDA. So each equipment object are labeled with RFID tag, and the students hold a mobile device to equip RFID reader so they can touch it. After touching that, wireless communication are around, and to enable the communication between mobile device and the computer server that executes the system, learning system. So the students, they have guided to learn those devices in the science park. So you can see that photo is very cute. The student are look for it. He was studying, and the other classmates are what he have choice. Okay, he had choice at that time. So the step 1 of the system will help the student to find the location of the target device, and this system will introduce what is the how to operate this device. So what is the device name, and you can touch the RFID, and then you can follow the instruction, and after that, okay, the system will teach the student to operate the device and check if the results are correct. So the student can do following the instructions and check the answer correct or not. Okay, if the student correctly answer the question and they operate the device correct, they will show some encouraging information for the students and guide the student to the next target device and repeat they will do the same thing in every device. So that is study about 2010, and after the experimental design, we can see that is the students in the experiment group have significant better learning achievement than the students in the control group. Okay, and another one is about the Tai Chi, Kung Fu Tai Chi. So I think many of you maybe you can guess that is peer assessment based mobile physical education, because peer assessment strategy often used in sport or physical education. And so the motor skill learning physical education, the teacher need to teach the motor skill and provide the basic operation demonstrations. Okay, just like those photos, that is Tai Chi. So often we see what kind of people play Tai Chi. That is older men, older people, older adults, and they are practice Tai Chi maybe in the park just nearby your house. And less research has been conducted on the effective perspective, particularly among the younger practitioners, because it's for older adults, not younger. Okay, so but that is a course. So in the university, we have the Tai Chi course. So we want to use the peer assessment to improve their learning motivations and their maybe perceived ease of use and usefulness, and other about efficacy about play Tai Chi. So you can see that modules here. Currently, that's kind of research cannot be published because maybe it's replaced by learning management system, just like Chuang class. They can have the mobile physical educational model. You can have the material here, personalized material, and the peer assessment module and database to analyze the behavior. So the student can record the student learning videos and have the peer assessment, how many classmates they need to assess. And then during the assessment process, you can use their mobile phone to complete all the learning tasks. So that is is a different type of the peer assessments. They need to give the feedback to a comment to the student, to their classmates. So after the experimental design, we also can find that the students significant difference in their learning motivations and their self-efficacy. Okay, it's quite better. So we understand that in that edge, we know the advantage of U-learning approach is provide a personal guide and for individual students in the real world authentic scenarios, and provide some supplementary material and hints in the right place at the right time. Not just to provide materials, because there are so many platforms can do that currently, but at the right place at the right time, you need to analyze the learning behavior or their learning results, and motivate the student to learn, improve students' learning achievement and skills. So furthermore, we want to promote students' learning performance, more effective learning support or knowledge construction tool we want that is needed. They are needed. Okay, so that is advanced application that also I want to introduce today. This is learning in my tools or other learning strategies. Graphical organizers is kind of my tool, so I introduce the definition of my tools first. My tools are computer-based tools and learning environment which serves as extensions of mind. So Jonathan have described my tools as a way of using the computer application program to engage learners in constructive, high order, and critical thinking about the subject they are studying. That is the definitions. So you can see my tools used in our studies. We can separate to two kinds of my tools. The first one is today's topic, concept maps, the graphical organizer tool. It can help students identify the relationship because it's just like a tree. So between what they have observed in the field and their prior knowledge learned from the textbook, so they can use my tool to organize it. And grid-based my tool, just like Rapid Grid, many my friends maybe know that is quite high percentage of my research is about the Rapid Grid. So this helps the student to organize the information from identifying the difference. It's different, several targets, and we need to identify what difference between them, between a set of learning targets based on the feature of the target. So we don't talk about Rapid Grid today, but I can show the Rapid Grid. It is the simple type of Rapid Grid, just like a table. So that is the element. The element is what the learning target, and we want to use a set of attributes. The attribute is here, positive feature and opposite feature is a set, is a pair. So if cough, this is not cough, so that is totally opposite. And we use the relationship between them, that is a 5-scale rating mechanism to identify the learning target about the cough or not cough. 1 is cough and 5 is not cough. So what is the rating about the target? So the target is not cough, so it's 5. And the target is cough, so it's 1. This is not a good table because we don't see 2, 3, 4. But sometimes we use the 2, 3, 4. We can identify your opinion about those learning targets. So then it is not figure, but it is a good strategies about higher order thinking. Okay, it's proposed by this person, George Kelly. Okay, okay, just skip that. So in the graphical, in the organizers, there are diverse roles, because if we want to use only one strategy to ask the student to draw a concept map, we don't need the speech today. The diverse roles of concept maps in educational settings is what we concern that what they can, that kind of concept map can do. The first type, okay, the first type is also the basic type, is create personal concept map. Okay, and many researchers about using the access students to create their own concept map. For example, this research. Okay, and most of the time we use the expert concept map as a scaffolding to help the student understand the learning materials, or to ask the students to learn, follow the scaffold, or ask the student to fill out some empty concept in the big scaffolding. So in the expert concept map scaffolding, I can do diverse of the research here. And I want to introduce this one is using concept maps with instant feedback mechanism. That is a famous paper here. Okay, that is because the concept map, I told that later, okay. And the second, next is concept effect relationships. Okay, I also talk this later. And use the collaborative strategy sorry. Okay, to ask students work together, and there are many papers about how to ask the student work together in the field or in the game or in the virtual environment or virtual and physical together. So there's quite different issues about how to collaborate. For example, that is a paper about using the games and about using the ER diagram, okay, to know the program, okay, the program ability. So the first one, I introduced the interactive concept mapping approach for mobile learning. Okay, educators have indicated that because once we ask students to draw a concept in traditional environment, the students just give the teacher concept map, and maybe they had the teacher need to use 1 week to have to see the concept map and return to the student the next week. That's too long. Quite currently. So the concept map approach with an instant feedback mechanism is proposed to support in-field mobile learning. Okay, okay, that is what I say in several days to return the concept map back. So you can see the student need to draw the concept in previous stage, maybe in the in their tablet PC or in a computer room, and then they can use the mobile device to see that the whole concept map they have drawn, they have done, and then they can browse the current concept map here, use this item, and then they can proceed the learning test because they're already in the field. So they can watch the real target and see what they have done in the map. Okay, that maybe some data missed that they want to add that in new information they just observed. So they can use the note and to add the list into their notes. And after the observation activities, they can modify their concept map. But while the learning process, the system can detect, they give them some hint. Are you sure that the relationships are correct? Okay, if you're sure, you can press the go button to access the supplementary materials to check that. So once the students submit their concept map, the student can detect the relationship is correct or not. For example, that is some mistake. So you can modify it. You can check this to modify, and this is a problematic propositions here, and you can check it, and then you can modify. Just use your mobile phone, and then submit the modification request again. Because the instant feedback of the to the students, that is what strategy the student in experimental groups of used, and then the another one is a conventional concept map oriented mobile learning. So you can see for the post-test scores is significant difference. The students in the experimental group has better grade to the better than the control group, and then concept map scores also better, and the students' attitude towards the science learning is also better in the experimental group. So that is the research in this paper. And another one, we want to use the adaptive game-based diagnostic and remedial learning system based on the concept effect model. That is what the concept effect model. The course is a mathematics course and use the game-based learning, and they use desktop or tablet PC. And the measurement is about learning achievement and the mathematics self-efficacy and learning attitude and the mathematics anxiety and the cognitive load, just like that. So in the first step, we ask the teachers to provide the correct order about how to learn the concepts. That is concept-effect relationship. For example, the student need to learn C1 first, that is addition and the subtraction of integers, and then finish that. After they finish the concept, they can learn C2, concept of integers, and then they can learn about the means of equal measures C3, C4, and then C5, 6, 7 to 9. So that is an order for the concepts. For that, we ask the teacher to provide before the learning the research, and then we ask the teacher to have the questions. If the student fail to correctly answer the questions, what question? Every question have some concept inside, and with different percentage. So we ask the teacher to give us this table. So if the students fail to answer some questions, we know that what concept they failed to learn in the current score. So we can analyze it. And after we analyze it, we can know that the photo here. Individual students, the span of comprehension for each concept, and calculate on the basis of CR diagram with error rate. If they're higher to the error rate, they need to remediate it. They need to study it again. But we also create a pathway to help the student to learn just like this way. Okay. So that is what the system we use as a student log in the math scan, they need to learn first. So they access the concept, and if wrong prompt learning materials are provided to the students with the concept, and they finish to learn the concept. Once they finish all of the learning materials, they can into the test. So they can find our learning diagnosis and doing the remedial learning path, and start the remedial learning process, and then study the remedial learning materials, and doing the test again. If answer correct, they finish that. If answer wrong, the wrong answer, they need to learn it again in the game. So that is the learning scenario. It's triggering about the fraction task, and the student need to choose the correct answer. And then that is a learning guidance for the students. If you want, you can look about the video again, and then you can get the test again. And if the student's correct answer the student can gain energy and keep moving to the next step. Okay, and this one is provide students with instructional videos to help them to do the remedial course. So the last research here, I want to introduce not every kind of concept map research in the previous diagram. This is AI-based. AI-based Oregon-style debate automatic test feedback learning system. What is Oregon? Okay, Oregon is debate learning. The debate learning requires meaningful questions and formative feedback from teachers. So since debate education is not a formal curriculum in Taiwan's education, so students, if they want to learn about how to debate, they mainly learn debate in clubs, in school clubs. So therefore, the learning resources are not balanced. Usually, it's no teacher. Learning resources maybe maybe it's not quite enough, and formal teachers are insufficient. So the Oregon style debate system is developed by Professor Gray at the University of Oregon. The Oregon is the most commonly used in Taiwanese debate competitions, and one of the most important features Oregon competition system that is increase inquiry to increase interaction between the two groups, and then divide to two parts, or usually divided into two parts. The first one is argumentation, and the second one is question. So this is our system. The system diagram as follows here. The interface of the student to put text inside, because they need to put text to, if they have teacher can give them feedback, but they don't have teacher. So they can use the system. They have the text input, put the text inside, and then in the right, in the diagram box of the left, it shows the text input by the students. And here is the expertise feedback. The images show that the student scoring and the feedback here. So that is system can provide to the students. And based on the content of the text, the system extracts the connection between concept and the generated concept map, providing visual feedback to the students. And this is the expert. On the left is a student concept map, and with indications of which concepts are correct, and or missing or incorrect. Here you can see that what is correct, missing, and incorrect. Okay, and here is the concept of it have been pre-stored in the database, also showed to the students. They can compare that. Okay. So the question is about the death penalty, and you can see the description here. Okay, and next in the second, that is the second function of the system, the teaching feedback function through question. So by discussing with experts and building a decision tree, the system provides some argument here, followed by the displaying options for students to click. They can click this. Okay, and then many debate issues are continuous. So based on the student choice, a different click, the system will lead to different response, similar to the chatbot format. Okay, finally, it can analyze which options are the bad question methods and provide feedback to the students. So it is the end of my speech. And research issues of graphical organizer based in field mobile learning, we can see that maybe the first one, we reconsider the roles of physical organizers in educational setting. For example, you can use a guiding strategy for problem posing, and using graphical organizers in different contexts, such as examples, digital gaming contests or flipped classroom contests, and investigating students' concept mapping behaviors in individual or collaborative learning activities. So maybe you can see the diagram is changed. Here is the AI-based concept map, and maybe you use the problem posing and question and the flipped classroom and many strategies to put in the different concept map strategies. After that, I think we have many concept map research in the future. So thank you for your participating. Thank you. Okay, this is
thank you very much. Yeah, thank you very much. Let's applaud again using the icon to thank Professor Chu's wonderful research presentation. Okay, so now it's the Q&A session. I'm wondering if any of the participants have any questions. You can, actually, I see one questions. Yeah, Professor Chu, can you see that from the Q&A? Yeah, it's a question from Professor Chu Kung Fu. Okay, Carol, your microphone is off. Carol, Professor Chu, your microphone is off. Your microphone is off.
Yeah.
Okay, it's
I
on.
know,
It's
I
on
know,
now.
sorry.
Okay, so there's
Okay.
one question from the Q&A from Professor Fu.
Yes, I
Suppose,
just
yeah.
read it.
So for all other people, all other participants, you can choose either ask in person or you can put the question in the, you can also post your question in the Q&A, the button, using the button, yeah.
Yes.
Okay.
How can you instruct them? Okay. I think the students need to cultivate their collaboration skills in the collaboration learning activity. If they don't have, because they need to work together to finish the learning activity, they can, and after that, they learn how to work together, how to work in the teams. So I'm quite sure in the mobile learning environment, students like to work together because so many studies improved that. And also in flipped classroom and other, you can see how cooperate with peers. What is the performance is better. So you can use the, but that is different collaboration or cooperation, because if collaboration, we don't use learning strategies to accent or collaborate together. If you use the cooperation learning activities, maybe you accent every number 1 and number 2, number 3, number 4 in each teams, they have different duty, and then they can work together quite structured in a structured way. And sometimes we access student to have the different duty. For example, the student need to do presentation. The student need to collect other answers. So you can test what kind of collaborative strategies is useful in your class, but you need to practice or you never know that.
Yeah, thank you, Professor Chu. Yeah,
okay.
And thank you, Professor Fu's question. Yeah, it's really a good question because in my class, one of my classroom is using the foldable table so that we can quickly move around the tables, rearrange. Yeah, but I think that there are a lot of strategy proposed by Professor Chu that we can incorporate into our future classrooms. Yeah, and I'm wondering if you have other questions. Actually, I see a question on the. Okay. I see one question from Anne, Shu Wen Anne. She was asking whether the host will share the recorded lecture video. Yes, yeah, we will share the recorded lecture video on the YouTube. So you can go to the YouTube channel on the APSCE. Yeah, and then you will be able to watch the video later. Okay, and I myself have a question. Yeah, I'm wondering because Professor Zhu introduced a very interesting Oregon-style debate system, and I know that it is integrated with the AI and chatbot.
Yes.
And I'm wondering if we would like to implement a similar system with the incorporation of AI and chatbot. What kind of equipment and technological knowledge background should we obtain
Mm-hmm.
in order to do the similar system?
Okay. Because the system is created by the use the deep learning strategies, and we have the text in the debate test. Collect so many debate tests, and in that that's issue, and then we use the deep learning to train. So that is quite different with the current chatbot. Yes.
I see.
So, but
yeah.
I'm not sure if I answer your questions.
Yes,
or you
yes.
can.
Yes,
Okay.
yeah. I'm actually asking this kind of question for many other people, perhaps a lot of people who are interested in implementing similar systems.
Yes.
Then they can probably.
If you use the current ChatGPT, they don't have the manuscripts by hand. So we need to analyze the hand. Usually the debate manuscript is by handing. It's not in the digital content.
I see.
Yes, so maybe can do that. Yes.
Okay. Thank you.
Okay, thank you.
Do we have other questions from the participant? If not, I have another question for you.
Okay.
Yeah, because you just introduced a study related to Tai Chi. To train Tai Chi for older adults. I think I'm very impressed. I'm very impressed by this kind of research, because usually we do research with college students, with elementary, high school students. We rarely do research with older adults, because there are a lot of challenges. For example, collecting the questionnaire may be a challenge, because some elders may have problem hearing what you are saying, and a problem writing the questionnaire. So I'm wondering if you have encountered this kind of challenges, and how you overcome these kind of challenges. Yeah.
Okay. Jerry, actually, the participants are undergraduate students in that
I see.
That study. But I think in your questions, we also have to I have done some research for older peoples, and if the older men they play Tai Chi, I think they can understand what you said, but you need to just ask them and help them to type it.
I see.
Yes.
So instead of asking them to fill out the questionnaire,
yes,
maybe we can ask them ask question one by one, and then record know the question, the answer.
Yes,
right?
Yes, because it's a situation for them. They need to have someone to talk about. Just like our parents.
That's right. Okay. Do we have other questions from the audience? If not, I think today we have really a great speech for us, and
thank you.
We understand the graphical.
Very good.
Yeah. Thank you, and we understand. Thank you. Yeah, and we understand the graphical organizer-based in-field mobile learning, from the VR, from the concept map, from different kind of studies like Tai Chi and Oregon style debate system, and we really learned a lot from how we can not only the technological part of this kind of systems, but also how we can incorporate this kind of system into our research in the future. So we really learned a lot. Thank you very much.
Thank you.
Let's give Professor Zhu an applaud again using the icon.
Thank you so much. Okay.
Thank you. And I just want to remind you of the 2 slides that you can for the participants. You can take a look at the slide at your screen. yeah, this will be our next APSCE webinar, and we'll welcome you to participate it again. Yeah. So let's.
Professor
Yes.
Ono.
Yeah. By Professor Uno, who is the famous
No.
professor in Japan. Okay. Yeah. So this conclude our webinar. Yeah. Thank you very much for all your participation. Thank you.
Thank
See
you.
you.
Bye bye. See
Bye-bye.
you.